As we all know, this Insta360 GO gets pretty hot in the FPV 5-minute recording mode. So we're looking at ways to cool it down, because if it stays hot and you try to do another recording, it'll cut it off using basically thermal shutdown. So one of the tests I wanted to do was to run it as I'm showing here, attached to metal. This is, again, it's on my steel shelving here. So I'm just going to get the profile of what the surface temperature is of the GO as it's recording, and then as it's cooling down, to see how long it takes to get down to the original starting temperature. If I take a reading on the shelf here, 75, the front of the GO 75. So we'll get it started here. That starts it, or that turns it on, and one button, it's starting the recording process. So I'm going to every minute collect the data on the temperature of it, and then we'll go from there. Alright, we're coming up on 3 minutes here. I'll just do a quick reading. I'll show you what's happening with the temperature on the shelving itself. On the far end over here, we're at like the original 75. As I get closer, we get warmer and warmer. Right on the unit, it's 90. And it cools down, so you can kind of see how that heat is getting dissipated into the shelf. Alright, we're coming up on 10 minutes. I'll start over here. Shelving unit is at about 72. Ten-minute mark. I'm at 78. Alright, we're coming up on 15 minutes here. Just check the shelf over here from the 71, 72 range. It's like about 73.5. So from a thermal standpoint, what this says is the back cover here, which is actually plastic. On the other side of it is a magnetic material, and then there's the circuit board. And so the heat from the circuit board has to go through that magnetic material, which acts as an insulator. The back cover, being plastic, is also an insulator, so it takes a long time for the heat from the inside chip, which is measuring the temperature and controlling the point where the thermal shutdown occurs, is what they call a high thermal resistance path to the outside. So the only solution is to whatever surface you attach this to, you want that to be as cool as possible. The test we just did with using a steel metal shelf, which would be something like maybe in the field you'd attach it to the side of your car. Use that as the heat sink to help cooling it down. It still takes at least 15 minutes to get back down to the original temperature of that metal surface. I'm now thinking maybe my idea of putting this in a plastic bag and sealing it up and immersing it in water for 2 minutes is probably the quickest and most effective way, because that way you'll get the heat from the entire surface area of the GO to be transferred as a heat transfer path to the heat sink, which is in this case the water. If you got any other ideas, let me know.